Okay. So today I will discuss already the theoretical part has completed. So the preliminary knowledge on practical is required. So for this reason I am discussing on the theoretical part of the practicals. Okay, that is what is the molarity, normality, what is the molarity, normality, etc. Okay, let's wait some time. Now is it clear? Now is it clear? Okay. So today one experiment, how to prepare m by 10 sodium carbonate solution, m by 10 Na2CO3 solution. Can you do it? M by 10 sodium carbonate solution. So here the strength is 1/10 of its molar solution. Okay. So how to prepare this? So first of all, calculate the molar mass of sodium carbonate. So sodium carbonate molar mass equal to 106. So m by 10, that is to prepare m by 10 1 liter. Suppose we are preparing a solution of 1 liter m by 10 solution, 1 liter. So m by 10, that is 10.6 gram should be weight, and then the rest of the volume should be filled up by water, that is distilled water. Okay, the weighted by weight, and it should be taken in 1000 ml volumetric flux. But basically what we do, basically we prepare 250 ml m by 10, basically 250. Then what to do, this is for 1000 ml. So 10.6 by 4, this is equal to 2.65 gram. So 2.65 gram should be weighted, and then it should be taken in 250 ml volumetric flux, and then the volume makeup is required to prepare the m by 10 standard solution of sodium carbonate. In the same way, how to prepare m by 10 oxalic acid? 1 liter, this is m by 10 oxalic acid. So how to prepare this? So for this, first of all, just like the previous, the molar mass is 126 gram. Now m by 10, so this is 12.6 gram. 12.6 gram. Now if we want to prepare 250 ml, then 12.6 divided by 4, that is 3.15 gram. 3.15 gram should be weighted by the electronic balance, taking the weighing bottle, and then it should be placed quantitatively on the 250 ml volumetric flux, and then the rest of this should be filled up by volume. First of all, just volume to some extent, and then shake it so that the salt may dissolve, and then fill up the volume. Don't fill up the volume to up to the mark. Okay, there may be some wrong. So this is the preparation of m by 10 oxalic acid. Now how to next one is that how to dilute one concentrate solution. How to dilute? Because in the rack, in the reagents rack, the strength of the acid are different, that is the 12 normal or 36 normal, these are the normality. Now the normality or molarity are different by one factor. It depends on its the acidity or basicity for base, or for the salt it is the number of cations or anions present on that and their number. Okay, next, how to prepare 250 ml 5 normal HCl from given 12 normal HCl. So 250 ml, we want to prepare 250 ml 5 normal HCl from 12 normal HCl. Okay. Now there is a rule, V1S1 equal to V2S2. What is V1S1? This is the volume of, suppose acid should be taken, S1, that is here 5 normal. Okay. V2 is 250 ml and its S2 is 12 normal. Now one strength is unknown, that is volume as acid, it is V1. So V1 into 5 normal into 250 into 12 normal. So V1 equal to 250 into 12 normal by 5 normal. This is 25, sorry, this is 50, okay, there is some wrong. Volume of acid should be taken, this is V1, and this strength is not 5N, this is 12N, this is 250, this is 5N. Okay. So here V1 into 12 normal equal to V2, that is 250 into 5 normal. So V1 equal to 250 into 5 by 12. This is equal to roughly 20.10, 08. This is 20.08. So it is 0.4010, 100.4. 5 into 250 by 12. This is 0.4. 12.8, yes, 12.8. So it is 104. 104 ml of concentrate acid, 104 ml of 12 normal acid should be taken, and the volumetric flux should be of 250 ml, and previously the water should be there, otherwise when we add water to acid it is a explosive reaction. So first of all, when you calculate, you add 100 ml of water to them, then overall the volume becomes 2005 ml roughly, and then the 45 ml will be done at last. Okay. So in that way you can liquefy a concentrate acid solution. This is very important, sometimes it is required. Next one, you have to mention the uh, solution, that is you have to mention the procedure also when you will write this titration part. Only in titration you have to write the procedure. Next is that, already have you attended the practical already? Have you attended any practical? Srijata Sarkar and Bhavya Sao attended any practical? Already one practical was done. What was done on the practical? It is sodium hydroxide versus oxalic acid. What practicals done on that day? It is sodium hydroxide versus oxalic acid, I think. Sodium hydroxide, yes, sodium hydroxide and oxalic acid. So you have got the preliminary knowledge on that. So for this, there is another one practical for you, that is hydrochloric acid versus sodium carbonate, HCl versus Na2CO3. This is the another one. One, you have to do any one out of that two. You have to do any one out of that two. Either it is oxalic acid versus NaOH, or it is sodium carbonate versus HCl. So in sodium carbonate versus HCl, the reaction is that Na2CO3 plus HCl, NaCl plus CO2 plus H2O. We have to balance it, 2 NaCl, Na2CO3 plus 2 HCl, H2 CO2. Okay. Okay. So this is the balanced chemical equation. What is the indicator used here? Methyl orange. Methyl orange is an give its test on acidic range. Acidic range. That is it is around 3.5 to 4.5. Next one, what is the change? That is yellow to pink. It will be shown on the laboratory. Next one, the molarity of sodium carbonate solution is given. That is m by 20. Strength of sodium carbonate is equal to m by 20 or 0.05. m by 20 or 0.05 molar. Okay. So this is the strength of Na2CO3. Now when you will titrate it, first of all you have to take the hydrochloric acid in the burette and you have to pipette out sodium carbonate on the conical flask. Just add 2 to 3 drops of indicator on the conical flask and then cautiously titrate it. Okay, now I will move to the calculation part. Okay. So this is the volume of sodium carbonate taken. This is every time this is 25 ml. This is the volume of acid consumed. Now this data should be recorded. It is about 24.5, 24.6, 24.5 with respect to 3 data. If this is the average, then take the average value out of this, that is 24.5 ml. This is the average volume of acid consumed. Now the balanced chemical equation is there. Now the how to calculate the strength, that is M1 V1 of HCl, that is M1 of HCl into V1 of HCl by M2 of carbonate, V2 of carbonate. 24.5 is the ml. Now this factor, now just follow that. What is the numerical coefficient in the balanced chemical equation? In before sodium carbonate it is 1 and before HCl it is 2. So here the equation states that the stoichiometric coefficient of HCl. So stoichiometric coefficient of HCl here is 2 and this is of 1. Now HCl consumed, that is 24.5, and this is the M1 of HCl, which should be deducted M2, which is M by 20 volume 25. This is equal to 2 by 1. So M1 is equal to, this should not be cancelled out, this is 1 by 20. Okay. So 1 by 20, that is 24.5 into 20 by 25, this M. Okay. So it is roughly equal to 1, 25, 24.5, this is roughly equal to M1 24.5 okay, M1 equal to 25 okay, this is equal to 25 by 20 into 24.5. Okay. So this is roughly equal to 1. So 1 by 20, that is again 0.05 molar. 0.05 molar. So this is the calculation. So very much important is that the mass, this is the strength of HCl, M1 of HCl in molarity, V1 of HCl, which is consumed, M2 of sodium carbonate and V2 of carbonate. Na2CO3 numeric coefficient should be there 1. This is 2. This calculation is required throughout the titration. In each and every titration this is required. Okay. So this is the second titration you have to do, and with respect to that you have to calculate, the titration is there, determine volumetrically the value of N, that is number of water molecule. As you know that oxalic acid having 2 molecules of water, COOH whole twice 2H2O. So these 2 molecules of water should be quantitatively determined. The title is that the N number of water molecules of crystalline in washing soda, that is Na2CO3 NH2O, 7 gram of which have been dissolved per liter of the given solution, provide M by 10 HCl. So again M by 10 HCl, here strength will be changed, and the 7 gram, that is you have to calculate the strength of the sodium carbonate solution by the given weight. This is on the titration. These 2 practicals is on the titration. Understood? Okay. So this is on the physical part, that is only titration, and out of that there are so many practical, that is change in pH, here what we have to do, that we use such indicator which indicates the change in the pH. That is, for example, in the for example, the litmus paper, litmus is used as an indicator. Then what happens at the neutral, it is just like green. In that way, the basic range is the blue range, and the acid range is the red range. So there is a chart, there is the indicator chart, that is also called the color match. That is just like the color of the solution might be with respect to this, the compared pH, what might be the compared pH, it should be detected and it is recorded. That is, suppose 5 ml of NaO is used, then the color is that. Again 5 ml, the color is changes to that. So in that way, quantitatively 5 ml of the titrant should be used, and the value is the seeing the color. This is from chromatography, not chromatography, this is also called spectroscopy. That is, matching the color, we will calculate it just as a comparison. Okay, so one practical of you is clear, that is titration out of these two. So you have to write it in which way, that first of all the title, number 2 is that theory. The theory contains this is a primary standard or secondary standard, or any standardization is required or not. No, there is no standardization required. After the theory, you will write the procedure. Okay, procedure, then observation. In observation section, there will be the volume of titrant taken, volume of K-monophore or oxalic acid or HCl consumed, calculation. Calculation part contains this equation, and in this theory part you will write the compulsory, this is compulsory, the balanced chemical equation. Balanced chemical equation, it is compulsory, because this will help you to calculate also. Okay, the calculation and then precaution, 2 or 3 precautions. This experiment will takes you for 8 marks. Okay, this is the quantitative titration one. Okay, so this is the one part. Okay, so that's all for today's class. Next class, I will discuss some questions, or maybe it from the inorganic also. Okay, so thank you everyone.